Welcome to this explainer. Today, we are stepping straight into the exam room, and you and we're playing lead physician. Our patient today is the Cambridge Computer Science exam. Specifically, we're going to diagnose exactly why so many brilliant, hardworking students completely flatline on those massive writing code demonstrating object-oriented programming concepts questions. And more importantly, we are going to prescribe the ultimate foolproof cure to get those marks back. Now, I want you to picture this. We've got a dynamic split screen right now. On one side, we have Alex. Alex is basically a walking encyclopedia of computer science facts. If you ask Alex what polymorphism or encapsulation is, you are going to get a flawless textbook definition. But when faced with a real past paper question, say from the 9618 or even 9713 syllabus, Alex just overloads the page with raw facts. There's zero analysis. The result? A page that comes back covered in red ink. On the other side of our screen, we have Sam. Sam takes one look at the question, sees the clock ticking, panics, and rushes straight into writing lines of code. Sam completely ignores the specific command word requirements, completely misses the boundary conditions, and again, the examiner's red pen strikes without mercy. Look, whether you're building your foundational skills in the IGCSE courses like 0417, 0478, 0983, 0984, or 2210, or you're tackling the absolute beast that is the A-level 9618 syllabus, this scenario is just all too common. But today, we transform those red marks into green check marks. Let's start the clinic. So what's genuinely fascinating about this question is what the principal examiner reports actually reveal. It is a shocking truth. It's rarely a lack of coding knowledge that brings a student's grade down. Think about it. If you've made it this far into the computer science course, you generally know how to write a class, you know how to instantiate an object, you understand how to use inheritance. The fatal flaw is almost always rooted in specific, highly preventable symptoms in your exam technique. It's about how you approach the problem. Alex and Sam didn't fail because they didn't know computer science. They failed because they completely misunderstood what the examiner was implicitly asking them to demonstrate. They lacked a systematic approach to breaking down the prompt, specifically those command words, before their pen ever even touched the paper. They missed the underlying requirement to explain the why and the how, not just the what. Here is our treatment plan for today's session. 1, we'll look at the examiner's warnings. 2, we'll dive into analytical depths. 3, the OOP procedural framework. 4, the method mark strategy. And 5, critical analysis for top scores. Let's jump right in. Section 1, the examiner's warnings. We are going straight to the source to see what actually causes a failing paper. Okay, the absolute crucial point here is that examiners are practically begging you to avoid these 3 massive pitfalls. First up, being too vague. Writing something like, the object inherits data is incredibly vague. Writing, the car subclass inherits the vehicle ID attribute from the vehicle superclass is specific. It shows you actually know what's happening. Second, missing boundaries. Say you're writing a method to add an item to an array of objects. Did you check if the array was already full? What if it's empty? Those are edge cases, and omitting them literally bleeds marks from your paper. Third, lacking context. This is huge. If the exam scenario is about a hospital database, your variable names and logic must reflect patients and doctors, not generic terms like item A and item B. Before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, to cure these exact symptoms, top students use a secret weapon. We call it the PL framework. Point, evidence, explanation, and link. Every time you write an evaluative answer, you state your point, provide evidence from your code, explain how it works, and link it back to the specific context of the question. If you master PL, you master the exam. Section 2, analytical depth. It's time to move beyond the surface-level facts. Notice the massive difference here between an average candidate and a truly top-tier student. Let's bring back our friends Alex and Sam. When we look at Alex's answers, we see superficial breadth. Alex writes a little bit about inheritance, a little bit about polymorphism, a bit about classes, basically just throwing mud at the wall and hoping something sticks. But there is absolutely zero analytical depth. Let's do a live transformation right now. Imagine Alex wrote this. The code uses inheritance to make different accounts. As an examiner, that is an instant red pen mark. It's way too superficial. Now let's inject some serious analytical depth and watch that red mark turn into a bright green check mark. We rewrite it using our framework. The system implements inheritance by allowing the savings account and checking account subclasses to inherit the foundational balance attribute and deposit method from the bank account superclass. This hierarchical structure reduces code duplication and improves algorithmic efficiency when updating system-wide financial protocols. Boom, green checkmark. Do you see the difference? We just moved from simple rote knowledge to advanced critical analysis. You must use systematic analysis and evidence-based reasoning to truly demonstrate your understanding. Don't just tell the examiner what object-oriented programming is, you need to prove to them exactly why it is the most efficient choice for the specific problem sitting right in front of you. Section 3, the OOP procedural framework. This is your ultimate success blueprint. By forcing yourself to rigidly follow this 5-step procedural framework, you essentially guarantee your success. Let's break this down step by step. Step 1. Identify key elements. Listen, before you write a single line of code, you need to highlight the nouns and verbs in the prompt. The nouns, those become your classes and attributes. The verbs, those become your methods. It is literally a cheat code hidden in plain sight. Step 2. Apply relevant principles. Look at the problem and ask yourself, are you going to need encapsulation here? Is polymorphism required to handle different data types fluidly? Select your tools before you start building. Step 3. Execute analysis with clear working. This is where you actually draft your algorithmic logic, making absolutely sure you are documenting your steps. Step 4. Verify results. This is your boundary check. Run a mental test case with an extreme value through your logic. What happens if the input is 0? What if the string is empty? Step 5. Present an appropriate format. Use the correct pseudocode or program code syntax strictly defined by the Cambridge syllabus. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now, if you ever feel stuck or get that brain fog during the exam, remember to use a visual story method to encode and recall these complex object-oriented programming concepts logically. Think of it like this. Imagine a class as a cookie cutter, and the objects as the actual cookies you bake. Inheritance is like a child wearing their older sibling's jacket. They get all the features for free, but they can sew on their own custom patches. Encapsulation is a heavy steel safe with a keypad. The sensitive data inside is hidden, and you can only access it through the approved method, which is punching the code into the keypad. Let's do a quick interactive workshop right now. Challenge 1, data scan. We're putting 60 seconds on the clock. Imagine a complex UML class diagram in front of you. You spot a user box at the top and solid arrows pointing down to admin and guest. Your visual story should immediately trigger. Parent to child, that's inheritance. Training your brain to rapidly extract the core trend from visual data sources is an absolutely critical time management skill for the 9618 paper. Section 4, the method mark strategy. Let's talk about the ultimate safety net. I genuinely cannot overstate how important understanding the Cambridge marking philosophy is. The examiners want you to know that showing systematic working and clear notation is so incredibly critical that you will be awarded process marks, what we call method marks, even if your final execution completely fails. Let's play challenge 2, find the flaw. Listen to this scenario closely. Sam has exactly 60 seconds left on the clock. Sam needs to write a method that calculates an employee's end-of-year bonus. Sam panics, rushes, writes an incredibly messy loop, gets the mathematical formula completely backwards, and doesn't write a single comment. The result? 0 marks. Now, imagine if Sam had utilized the method mark strategy. Even if the underlying math formula was totally wrong, if Sam had just properly defined the method signature, declared the variables with the appropriate data types, initialized a basic counter, and added a quick simple comment saying /loop through array to calculate bonus, Sam would likely pick up 3 or 4 method marks out of a possible 6. And that is despite the final answer being completely incorrect. Never, ever leave an OOP coding question blank. Deconstruct the question, write the framework of the class, define your constructor, outline the methods. You are harvesting method marks every single step of the way. Section 5. Critical analysis for top scores. This is how we reach the peak. The absolute top scoring candidates don't just write code, they demonstrate high-level evaluative thinking. When they are faced with a complex scenario, they don't just jump at the first idea, they consider multiple solutions. Should this list of objects be stored in a standard static array, or should it be a dynamic linked list? They analyze the trade-offs. For example, an array provides really fast direct access via an index, but a linked list allows for dynamic memory allocation, which is much better if we don't actually know how many objects we'll end up having. They openly acknowledge the limitations of their choice. However, a linked list requires more memory overhead for the pointers. And finally, they justify their decisions with crystal clear evidence. Here is challenge 3, speed writing. You have 30 seconds to write a perfect peel paragraph justifying an array. It should look like this. Given the scenario states the maximum number of hospital beds is fixed at exactly 500, a static array of objects is the most efficient choice because the maximum size is known and memory overhead is minimized compared to a dynamic structure. That is exactly how you secure those top scores. As we pull together our final system, remember that when evaluating alternative OOP approaches, your comparative analysis has to be completely airtight. If you're asked to compare using a 1D array of records versus a full object-oriented class structure, you need to use specific connectives, like whereas or conversely. You need scope, meaning you identify both similarities, like both structures group related data items together, and differences, whereas a class can also contain methods to actively manipulate that data. You absolutely need proof, referring directly back to the specific exam scenario. And you must have an outcome, a definitive conclusion on which approach is objectively better for the given problem. If you practice structuring your answers against this exact checklist, utilizing command word decoding, the Peel framework, and smart time management, your mark potential goes straight from 0 to 100%. You are hitting every single assessment objective exactly how the examiner demands. Listen, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. So as we close our diagnostic clinic today, I want you to ask yourself a serious question. The next time you face a blank page and a ticking clock on a 9618 past paper, will you panic and just list random facts like Alex? Or will you deploy the 5-step procedural framework, claim your method marks, and systematically prove your analytical depth? The choice, and ultimately the grade, is entirely yours. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Until next time, keep analyzing and keep coding.